Hello again, I'm Tommy Baggett, and I'm back with another episode of Byte-Sized Mobile Dev Tips. In this series, I discuss common things I've encountered in various mobile projects with the hope that it'll be helpful to you when you need them in your projects. In today's episode, we're going to look at the Apple Developer Enterprise Program. It allows you to control distribution of your organization's in-house iOS, watchOS, and tvOS apps. Enterprise apps aren't distributed through Apple's App Store. Instead, you host them yourself or use a third-party service. And even if you aren't planning to use the Enterprise program, Apple can and will reject your app if they believe your app only targets users within your organization. Also, without the App Store, there's no app update process provided. Stick around for this episode as we're going to look at a possible solution for app updates, including a sample Xamarin.Forms project. Before we jump into the app update mechanism approach I took and the sample solution, I'd like to talk for just a minute about the differences in the regular App Store program and Enterprise program experience when it comes to the Apple Developer Portal. If you've done iOS development before, you know this is where you go to create the provisioning profiles and certificates needed for iOS development and distribution. Currently, we're looking at the account for just regular App Store development. We see three main options on the screen, the far right one being App Store Connect. There's also an App Store Connect menu item on the left just below Certificates, IDs, and Profiles. But if we look at the Developer Enterprise program, we can see that item is removed both from the main options on the screen as well as the menu items on the left. Other than that, the interface is pretty much identical between the two programs. Likewise, if we look at certificates with the App Store account on the left, the Enterprise account on the right, again, pretty much similar, pretty much the same. Same with profiles, except Apple does call the distribution profiles for an Enterprise account, seen again on the right here, iOS Universal Distribution, as opposed to just iOS distribution in an App Store account. There's a little bit more difference when you go to actually create certificates or profiles. Just in the production section in the bottom half of the screen, you can see the App Store and Ad Hoc option for an App Store account on the left, and an in-house and Ad Hoc option for the Enterprise account on the right. Then for provisioning profiles, again, a little different for distribution. An App Store account has App Store, tvOS App Store, Ad Hoc, and tvOS Ad Hoc options, while the Enterprise account on the right has in-house Ad Hoc, tvOS Ad Hoc, and tvOS in-house options. Once you get your provisioning profiles and certificates created, it doesn't really matter if you're using the App Store or Enterprise accounts. Apple development, iOS development works pretty much the same. I also mentioned in the intro to this episode that you can use a third-party service to host your enterprise apps. If you're interested in looking into that option, Google Mobile Application Management. That's the term used for these services. You'll find white papers and other sources of general descriptions about mobile application management, as well as the companies that provide the service. We're going to quickly take a look at one such company. It's just an example. I'm not endorsing them. I haven't used them. I've just looked at them and considered them in the past, just to give you a point of reference. We're going to look at their pricing. This service provides an App Store experience, automated updates, lots of other features too. Pretty nice service. But if you have a large number of users, it can become expensive. They offer a Plus plan, which is $149 per user per month in euros. The Plus plan requires a minimum of 20 users, supports up to 100 users. If you have over 100 users, then you have to move to the Enterprise plan, which is €249 per month per user. And again, that's a minimum 100 users. If you're US based like myself, you also have to take the currency conversion rate into account. So for the minimum 100 users for the enterprise plan, you'd probably be looking at close to $300 per month. If you have 1,000 users, that could be $3,000 US dollars per month. So just consider that and compare that with how often you expect to update the app. If you're going to have multiple apps, then an app store experience makes even more sense. It just really depends on the specifics of your project. If, like me, you decide that self-hosting makes sense, then stick with me and we'll talk about the approach I took to handle the app updates. The first step in our in-app update solution is to get our app's current version number. Next, we need to fetch the latest available version number from our servers or services and compare the versions and fetch change information from our servers or services if needed. We then display a new version available messaging type display to our user, and we install the new version of the app if directed to by the user. Then finally, the user relaunches the app after installation. Just a quick note on this, I did research trying to automatically restart the app after installing the update, and I couldn't find a way to do it just when self-hosting the app updates. If you've come up with a way to do it, I'd love to hear about it. Please leave a comment in the video here or reach out to me directly. All right, so now we're going to jump into Visual Studio and take a look at how these steps were implemented for Xamarin.Forms. I've opened Visual Studio, created a new Xamarin.Forms project targeting iOS and Android with a net standard library, using the blank template, which gives us our Welcome to Xamarin.Forms app you see running on my device here. We're going to work quickly through the code for this sample since there is a good bit. I'll provide a link to the GitHub repo that contains it so you can review it fully at your own pace. But right now we're going to take a pause. I'm going to add some folder structure to our project, come back and talk about it briefly, and then we'll continue to move through building our sample. Okay, I've created a few folders including services, view models, and views in the shared project, and also services folders in the Android and iOS projects. We'll explain what those are used for as we proceed through the sample. I also moved the main page XAML file that's created as part of the Welcome to Xamarin.Forms starter app into the views folder and changed the namespace in both the XAML and its code behind, as well as the app XAML code behind that references it, so that everything would compile and run successfully again, and as we can see, it is running again. Our next step is to start making some modifications to the main page. We're going to add a couple of labels that are going to tell us the current version information for our app. Taking a look at the changes we made, we added a couple of labels with text properties binding to a view model we're going to add in a moment here, to properties called app short version info and app version info. All right, I've added the MainPageViewModel class to my view models folder and created properties that we referenced in our main page XAML view class. For now, it's just static text that says app short version followed by question marks and app version followed by question marks. I also added the FODI Weaver for property changed so that it's going to take care of handling the boilerplate code for the iNotify property changed interface. That's a topic we talked about in the last episode. So that's going to take care of that part for us. And then for the code behind for the main page XAML file, I just added a assignment to the views bind-in context property to a new instance of the main page view model. As you can see, it's running and we see the results there on my device on the right. So the next step will be to work on retrieving the current version of the app. So we're going to take a look at how that app information or version information is stored for both the Android and iOS projects, and the service that we're going to create to retrieve that information. Returning to the main page view model, if you recall, we created two properties, app short version info and app version info. So the service that we're going to create that provides that information is called the AppVersionService. We're going to create an interface that defines it in our cross-platform code, and then platform-specific implementations of the service in each of our Android and iOS projects. So we need to get two different pieces of version info information, the regular version and the short version. And so I've added two string properties in the AppVersionService that provides that information. Looking at the Android implementation, we can see that we use the Android package manager, its getPackageInfo method, to retrieve the version name property for the short version and the version code for the long version, the full version. Next, we're circling back around to the iOS implementation of the AppVersionService interface, and we can see here that we're using the app's main bundle, the object for info dictionary method, and getting the CF bundle short version string and CF bundle version string properties respectively to return the short version and version properties that the interface requires. With our platform-specific implementations of our AppVersionService interface implemented, we're going to retrieve the current platform's version by using Xamarin.Forms Dependency service. That's a two-part process, the first part being to apply an assembly attribute to the platform-specific implementations, declaring that it's a dependency. We do that on both the iOS and the Android versions. And then back in our shared code in our view model, we use the dependency service get method to retrieve the concrete implementation for the current platform. We assign that to a read-only getter or a read-only property called AppVersionService I've declared here. And once we have that available, we can actually use it here in our two string properties to return either the short version or full version info that we want to display on the screen. With those pieces in place, we've restarted the app and we now see the correct version information displayed on the screen. Our next step is going to be to add a button to this view that says Check for Updates, and when clicked, it will make use of another service we're going to add that retrieves the version number of the very latest release of our app. Alright, I've added a new button here to our view that says Check for Updates. I've added a binding for a command to CheckForUpdates command. That command is defined here in our MainPageViewModel. It executes a private method called CheckForUpdates, which we see is here. That method is executed, or the command is executed, of course, when the user taps the button, which we see here on the screen, CheckForUpdates. And that results in this method being executed, which uses a new CheckForUpdatesService property on it called IsUpdateAvailable. It calls that method, and based on its response, if there is an update available, we're going to change out the page that's being displayed to the user from our main page to a new Update Available page. So we're going to take a look at the page and view model for the Update Available information in a minute. First, we're going to take a little bit of a look at this CheckForUpdates service. This new service includes a couple of methods that we're going to use. The first is IsUpdateAvailable. That's going to let us know if there is a new version available, and also if updating to that version is required or optional. After that, if there is a new version available, we're going to switch the page on the screen to a page that displays what changes have been made between the currently installed version and the new version. That information is retrieved from this service by calling the GetVersionChanges method. In your production project, I would expect that these services methods would make a web service call, or at the very least retrieve a static JSON data file to get the information they're looking for. However, in this demo project, we're going to just mock the response up. We'll save web service calls and things like that for another episode. So first, we're going to expand the IsUpdateAvailable method and take a look at what's going on here. First, we need to find out what the latest version of the app is that's available. In this case, I'm going to create a mock of a response called latest version response, which if we take a look at that, we can see it returns a string that tells us the version number of the latest version, and also a Boolean that tells us if that update is going to be required or optional, which means we'll give the user the option to install the update later. We go back to the service here. Once we've got that latest version, you can see we also get the app version service here that we used earlier to display the current version of the app on the screen. Now we need the current version of the app so that we can compare it to the latest version to determine whether or not there's an update available. Once that comparison is completed, if it's found that there is an update available, the response is going to indicate that by doing this comparison to see if latest version number is greater than current version number, and also just returning the isUpdateRequired property that came back to us in the latest version response. The isUpdateAvailable response is basically just a couple of read-only getter properties. One that says whether or not the update is available, the other saying whether or not it is required. So we'll return that. If for some reason the parsing of this information fails, we're going to just return a newly instantiated isUpdateAvailable response, which will result in both of those properties indicating there's a new version and that the update is required, defaulting to false. The second method in this service, GetVersionChanges, would also normally make a web service call to retrieve its information, and once received, it would do some parsing of that data, comparing the current version to the changes and filtering out those changes that are for older versions than what is currently installed, then returning the changes that are just for versions newer than the currently installed version so that those can be displayed to the user. As before, we're just using a private method to create a mock of the response. The update changes response is a little bit more complicated. It includes a current version property, latest version property. That's primarily for information that's going to be displayed on the updates available screen. Latest version release date, the actual link to the new version of the app for downloading and installing, and then a list of version detail class instances that tells what the changes were for each of the versions in between the currently installed version and the latest version. Each one of those version details instances includes information including the version, the release date of that version, and a list of strings that detail the changes that occurred in that version of the app. The final two pieces are the new view and view model used to display these update changes to the user so they can make a decision whether or not they want to install the update. We're going to take a look first at the update available XAML page that defines the view. It's a little bit complicated, and so is its view model, so I'll go through these. First, we have a page appearing command where I bind a command that's on the view model. This is kind of taking the place of the, or providing a way for the onAppearing event in the content page class to be bound to a command on the view model. This is similar to like Prism MVVM, for example, having onNavigating2 methods in their view model classes. But since we're just using stock Xamarin.Forms, I kind of facilitated that by adding a custom property here. In the code behind here, we can see I added this bindable property and set it up to where this could be established. And then here in the constructor, I added a listener for the appearing event to call onAppearing, and it checks to see if page appearing command has been assigned and if it can be executed, and if so, then it will execute it. And so that way we can put the logic for calling our update available services from the view model for the update available page. Here in the update available view model, we've got some properties defined here, some commands. It's, like I said, kind of complicated, but not too bad. We'll see in a minute that we have an instructions property where we give information to the user at the top of the page. We have a Boolean that specifies whether or not the update is optional or required. And then in our constructor, we create a new instance of our CheckForUpdatesService. Again, if you were using MVVM, You would probably be using some sort of dependency injection container here to instantiate that for you. We also create our page appearing command, our install update command, and our ignore update command. Those are going to be used to respond to the user clicking the buttons. If it's optional, they'll have an option to ignore the update. If it's required, they only have the option to install the update. And then finally, the way that I'm implementing the display of the changes is to actually use a web view. I'm actually using a string writer to build the HTML content for display in that web view. And I'm just iterating through the response that comes back from GetVersionChanges, the information it tells me about each of the versions that are available, and building HTML content to be displayed in that web view that we'll see here in just a minute. Finally, once I've constructed everything, I assign it actually as the HTML source in the web view. Okay, so that's all the moving pieces. Now we're going to take a look at the app with these features added. You see we've got our Check for Updates button on the screen now. If I tap that on my device, we now see the new page that we added, the Update Available page. We've got some text instructions at the top, and then our web view here, we can scroll a little bit and see different version features that is being returned by our Update Available service. In this case, the values that I'm returning in the mock output indicates that the update is optional. So we do see the later button down at the bottom right, as well as the install option on the bottom left. The later button would not appear if IsUpdate required was true. Also, the version number that's being reported, 1.0.0.0, that results in all of the version changes that I have in my mock response being shown here in the output. I'm going to pause again, and I'm going to change the current version number of the app to 1.1.2.3 and run it again, and then we're going to see a difference in what information is shown for what's new. With that change made, and after restarting the app, we now see the 1.1.2 short version and 1.1.2.3 full version being reported on the screen. I'm going to tap Check for Updates again, and now we see that the only version change information that we're seeing is the latest version, the 1.2.3.4 version, and all the previous versions we saw when we ran the app last time are no longer displayed. Now, in this sample project, I don't have things set up to actually retrieve a new version of the app and overwrite the existing version of the app. So if I tap install, we're going to get an error because the URL that I've specified, example.com, and the specific path to the file does not actually exist. We're going to take a look at that file and that information just so you know what you need to do to make this work for your actual project. So there are a couple things that we need to look at. First, in our mock creation of the update changes response in the Check for Updates service, we need to look at the update link URI that is being returned. This is a special format file that points to a manifest.plist file that the enterprise app updating mechanism expects to retrieve. You don't specify your IPA executable file directly. Instead, it is referenced through this manifest.plist file. We come out here, we see I've placed example.com/manifest.plist. You need to obviously replace this with the actual URL where your manifest.plist file is located. It does need to be served over HTTPS, and it cannot require any login credentials. It needs to be secure over HTTPS with no login required in order for this to work correctly. So this is how you specify the first part. This is what's going to actually attempt to be downloaded by the app by assigning it to the web view as its source, which will trigger it to download it through the Safari browser. And then the important part is the information we have inside our manifest.plist. The manifest.plist is going to include 3 asset references. The first is the URL to the actual app update. Again, here I'm just using example.com. You would need to specify the full correct path to your latest version IPA file. You could have different folders for different versions if you want to make multiple versions of the releases available. You would require some enhancements to this solution I've provided, as we only expected to have the very latest provided to our users. But it would be possible to do by enhancing what I've done in this solution. So again, it needs to be served over HTTPS, don't forget that. The other two assets are images, a display image that is a PNG file, and then a full-size image that is a JPEG file. In the iOS project of this sample solution, I've created a folder called EnterpriseDistributionFiles. That is where this manifest.plist file, as well as these two image assets, are saved for your reference. So that's available for you to reference. All you're really going to have to do with the manifest.plist file is change the URLs for the references to these two images and to the actual new version of your application IPA file. And then when you implement the generation of the data being returned for this update changes response to be created, whether you do it in a static JSON text file or a web service or whatever, this update link URI has to be created and formatted just as it appears here in this link, except for the correct URL to where you have saved the file at on your server. So that's it for this episode of Bite-Sized Mobile Dev Tips. Don't forget to like, share, and subscribe if this episode was helpful to you. Visit these sites to learn more about the Apple Developer Enterprise Program, mobile application management, or to review my sample project source code. You can also reach out to me through my site, LinkedIn, or Twitter accounts with questions or opportunities to work together. Thanks for watching. Until next time, happy coding!